Good evening. Can you hear me?
Yes, sir.
Good. Okay. We are discussing about measuring instrument, right? In measuring instrument part, today we have final instrument of length measuring instrument. Length measuring instrument, final instrument. Okay, what we discussed up to now, we discussed about length measuring instrument, right? Length measuring instruments. In length measuring instrument, what is the first one we discussed? Meter ruler. The meter ruler is completed. Vernier caliper with all practicals and all theory. Vernier caliper is completed. Last week we discussed completed the micrometer screw gauge, practicals and theory, everything completed. Zero errors, least count, and human error possibilities, everything we discussed, right? Now you have to, if you have missed any part, I have upload all recordings into our April group. අපේ April group එකට ගියා නම් ඒකේ මම දාලා තියෙනවා. I have, yeah, in this, yeah, this is our groups. Make it, yes, I have sent all recordings starting from introduction session. All recordings completed up to now I have uploaded, and I have sent tunes for all students, right? I think now you all have tunes. One or two කවුරු හරි pay කරලා නැත්නම් තමයි tunes නැතු ඇත්තේ. අනිත් I think all paid students I have sent, I have post tunes. After that, the thing is you have to go through again. You have vernier caliper, again you have to go through and revise again and refresh your mind, refresh your brain. Micrometer screw gauge, again you have to go through and refresh how to read, what's the meaning of least count, what's the meaning of zero error, how to calculate the least count of vernier caliper, how to calculate the least count of micrometer screw gauge, how to calculate the zero errors of vernier caliper, how to calculate the zero errors of micrometer screw gauge. Okay, likewise what micrometer principle and vernier principle, you can have some, you can make a comparison, right? You can make a comparison and make a short note. Clearly you can make a short note. I think the least count of vernier caliper, you have an equation. Least count of micrometer screw gauge, you have an equation. After that, zero error, it is both same, right? Positive zero error, vernier caliper positive zero error, vernier caliper negative zero error. Micrometer screw gauge positive zero error, micrometer screw gauge negative zero error, right? You can make a very simple short note. Then it is very simple in future. Nowadays you prepare in short notes, your own self notes, wala hadana notes, they all very important for your final 6 months. Final 6 months. That means 2026 students now very important, very helpful. These previously made not short notes and their own notes. Now they are very useful. Now, as new students, now you can start. Walatam alut, you have enough time. You have enough time. Now you can start. Now you can start. Please, what's the method? Please go through again previous lessons, previous parts, and make short notes and everything complete perfect. Okay, that's the thing in your side need to be complete. ඒක තමයි ඔයාලා කරන්න ඕන. If you continue this process entire this 2 years, definitely you can get super result, super rank, super district, good district rank, and with it, you can get rank within first 100 island, merit island rank end of this journey with good Z value, with more than 3.8 more than 3.2 Z value. Okay, let's start. Okay, our today lesson, it's a new instrument that we called as traveling microscope. Traveling microscope. Why we call it as microscope? It is a length measuring instrument, no? Why we call it as microscope? Why appear microscope? Do you have any idea? Why we call it as microscope?
Because of its appearance.
Yes. Other reasons? Yeah, appearance is a one reason. What else? Others? Normally, I think you all have used light microscope, right? Light microscope you all have used in all level time. Okay, the appearance, the shape of the measuring instrument, it is same as light microscope. It is a one reason. The other reason, the measurement taking, it's just like observing like microscope. That's another reason. Measurement take gun, we get the measurement use as a traveling microscope use as normal microscope that's magnified it has a magnification. Okay, I'll show you. Okay, that they are the main reason we call this traveling microscope. Why it is traveling microscope? Now due to appearance and measurement taking method we can say it is microscope. Why we call it is traveling? Why we call this as traveling? Traveling क्या है? Traveling microscope. Microscope is okay due to appearance or whatever, or use method. Why we called as traveling? Any idea? Why it is called as traveling?
Being able to carry it to place.
Yeah, I'm not clear.
Being able to carry it place to place without any.
Yeah, but micrometer, screw gauge, vernier caliper also portable. But that we not called as traveling micrometer, screw gauge. එම කියන්නේ නැහැ නේ. Friction. What are the possible reasons? The reason this microscope can be travel. Travel means that we can move. That we can move in horizontal and vertical directions. I will show you. This microscope, it has a microscope actually. This microscope that we can move along the vertical axis and horizontal axis. Vertical and horizontal both axes. I got Vinuji? Understood? That's why we call traveling microscope. I think now you have some idea, right? Okay, now let's see can move. Now we can move to the instrument. Okay, actually this traveling microscope, first of all I will show you the instrument. Okay, this is the instrument. This is the instrument. This is the instrument. Okay, let's start from this part. Okay, this is the microscope. See, this is it has a focus tube. You don't need to remember these all parts because traveling microscope parts not asking in exam. Very simple. If you have very simple idea, that enough about traveling microscope, because in our previous syllabus they mainly given as an instrument traveling microscope, but in our new syllabus traveling microscope only mentioned. They have only mentioned traveling microscope is length measuring instrument. Okay, very therefore important things if you know that enough. But I hope to give you some additional knowledge about traveling microscope, but we have to complete quickly this. I'll give some additional practical idea, right? Okay. Who is my Rukshan? Okay. Okay, this is the microscope. You can see 10x. You don't need to remember these all parts. This is the eyepiece. Eyepiece mean lens, and this is a objective lens. This is a other lens that we can observe. Okay, that's a lens, eye lens. Okay, and this is a focus tube and focusing knob. I will show you. I will show you functions of each part. Just understand name of parts. Okay, total this part is a microscope. Totally this part is a microscope. This is a microscope. Okay, after that, this is a vertical knob. Vertical knob means rotating this screw, we can shift, we can travel the microscope in vertical axis. We can adjust the height from this stage. I got. We can adjust the height. We can adjust the height. And this is focusing knob mean is focusing knob mean we can focus. I will explain that later. Okay, that is a vertical support actually. These are all parts vertical support. This is a vertical support. This is a vertical support. And in this vertical support, there is another screw, right? There is another screw. And the main important thing, second thing you need to remember, this traveling microscope contains 2 vernier calipers. Actually, the traveling microscope also an instrument that is used vernier principle. Vernier principle. Okay, that's why but it use 2 vernier scale. 2 vernier scale. This is a 1 vernier scale. See, this is a 1 vernier scale. It is vertical, but there is horizontal vernier scale as well. Horizontal vernier scale and vertical vernier scale. The main principle of instrument is vernier principle. Vernier principle same as vernier caliper. Then all measurement reading, everything same as vernier caliper. Okay, measurement reading, 0 errors, least counts, everything same as vernier caliper, because in this traveling microscope use vernier principle. Vernier principle එක තමයි use කරන්නේ. Okay, this is a vertical vernier scale. This is a horizontal vernier scale. This is a horizontal vernier scale. See, 18 centimeter horizontal scale, 14 centimeter vertical scale, right? And there is an horizontal adjustable knob. This is a screw that we can shift this microscope in horizontal way. Horizontal way we can adjust. We can adjust in horizontal way. Horizontal way. And this is a horizontal knob. That one also we can use to adjust in horizontal way. Horizontal way. Okay, then how to take measurements using this instrument? How to take measurement using this instrument? Okay, now I told, clearly understand this part, very important. Now I told this instrument taking measurements same as using micrometer principle. Microscope principle. Micrometer is the instrument. Microscope principle, microscope method. Observing by lenses. Observing by lenses. So it magnify kalla. Vishal kalla tama bala. Harad. Okay. Now, if you observe eye lens, if you observe by this eye lens, you can see, very important. You can see, okay, think this is a lens. If you focus well by this focusing knob, you can see red color cross line like this. Red color cross line like this. Okay, if you focus well, we can observe red color cross line like this. Red color cross line. Okay, how to take readings, how to get measurement using this instrument. Okay, think I just want to get the, now it is a rubber band, right? Now it is rubber band. I just want to get the thickness of this rubber band. Thickness of this rubber band. Thickness of this rubber band. Okay, I'm going to place the object on this stage. That we call as a stage. I forgot. Okay, this is a stage. This is a stage. Place the object. Place the object on the stage. Stage and observe by lens. Observe by eyepiece, eye lens, right? If you observe, we can see the object and object with this cross line. Cross line we can see a cross line, and we can see magnified object. Magnified object. Normally it is 5x. 5x means multiplied by the object actual size magnified by 5 times. 5 times. Right? It is a magnifying lens. Okay. Now think this is the, okay, clearly understand this. Very important. Now think this is the microscope view. Microscope view. This is a microscope view, and they are the cross line. Red cross line. Okay. Now the first thing, this is my this is my rubber band. Okay, if you observe by this microscope, you can observe this rubber band like this with some thickness because it's magnified. Okay, maybe that loku ela pena with magnified. Okay, now if you observed, okay, using vertical and horizontal adjustable knobs, using vertical and horizontal adjustable knobs, we can take this microscope cross line like this. මෙන්න මේම ගන්න. හොඳට බලන්න. Think this is a microscope. Okay, using adjustable knobs, we can get the lens like this. මෙන්න මේ විදිහට මෙතනට ගන්න. Using adjustable knobs. The micrometer observation area, observation cross line get to the edge of the, adjust to the edge of the rubber band. Okay. Now, in the second step, using adjustable screw again, get the microscope view like this. මෙන්න මේ විදිහට ගන්න. Like this. Right? Now I can get the external diameter using this point measurement. Think this point measurement. Now it is horizontal thing. This measurement is horizontal, right? Now using horizontal vernier caliper, then මෙන්න මේ විදිහට අරගෙන මෙතන තියෙනවනේ vernier caliper එකක්, it is horizontal vernier caliper. What is my requirement? To get horizontal length, length difference. Okay, think this point value, this edge value මෙන්න මෙතන value එක the vernier caliper value was 4.8 millimeter and this point value මෙන්න මෙතන value එක the value of other edge 6.2 millimeter. Okay, now carefully understand we can get the external diameter by the difference of these two measurements, difference of these two measurements. Then actually the external diameter we can say 6.2 minus 4.8 equal 1.4 millimeter is the external diameter of this rubber tip, rubber band, rubber ring. I got understood? Any doubt? Yes, simple thing I got. Simple thing I did. First get the observe cross line into the edge of one edge. මෙතන එක edge එකකට ගන්න. Then get into the other side edge and get two vernier measurements and get the difference. Okay, that's all. Good. Perfect. Okay. Okay, actually, if you have some basic idea, that enough. Making him a very complex like vernier caliper micrometer type questions not asking. Just you need some simple knowledge because it little bit complicated instrument, right? But simple mechanism. Okay, now tell me, what is the main advantage of using this traveling microscope more than other instrument? More than micrometer, screw gauge, vernier caliper, what is the advantage of this instrument? Think. What is the main advantage? What's the main advantage? Yeah, less errors. Yeah, you are correct. Less errors. What is the reason for less errors? Errors are doing. Valahari. I ask, what is the reason? Comparing with other instrument, what is the reason more accurate? Yes, more accurate. I want the reason. Yeah, allow measurements by the difference of two measurements. Yeah, that one also correct. But there is another advantage, main advantage. There is another main advantage. Okay, that is the main advantage. කියන්න බලන්න ඔයාලා. High precise. Yeah, high precise. I asked, what is the reason for that? Okay, this is the micrometer screw gauge. Okay, what is the main advantage of ratchet actually? ratchet main advantage, we can avoid over tight. Do you remember? We can avoid over tightening. We can avoid over tightening, right? But if we try to avoid over tightening, micrometer screw gauge also we can't tighten perfectly in required tightness. On point we can't tight. And vernier caliper, it has a major issue. It has a major issue about tightness. In vernier caliper, it has a major issue, right? Why? We don't have any tight make a tight කරන්න පුළුවන්. We don't have any measurement. Person to person, this tightness can be difference. Tightness can be difference. But is there any, what is, now you can see. Now what is the advantage? What is the main advantage comparing with this instrument? Comparing with this instrument, what is the main advantage? Yes, object is free. Yes. කොහොමද ඒක හරියටම කියන්නේ? Very good. We can get measurement without contact. Instrument not contact with object. We can get measurement with some distance. Normally, remember when we adjust, always we have to maintain minimum 4-finger distance between object and microscope. Objective lens. Object and objective lens, we have to maintain 4-finger distance. මෙතන ඇඟිලි 4කවත් distance එකක් තියාගන්න ඕනේ. Okay, that is the main advantage. We can get measurement with some distance without contact with instrument. Without contact with instrument. Object not contact with instrument. Then overpressing and shape changes not coming. Shape changes not coming. Yeah, they all are advantage. That's the main advantage. I got. That's the main advantage comparing with other instrument. I got. Okay, what else other what else other advantage? Other main advantage, no any zero errors. We don't need to think about zero errors. Why? Always get the difference. අපි difference එකක් නේ ගන්න. Always get the difference. Vertical axis or horizontal axis, get difference. Then if there are any error, it's coming to both values. මේකත් වෙනස් වෙනවා නම් මේකත් වෙනස් වෙනවා. එතකොට that is no any effect to this difference. ඒ කියන්නේ zero error එකක් තිබ්බා කියලා, if there is zero error of this vernier scale, it is not affect to our final result. Right? Final result. Understood? Second point understood? The first point, we can get measurements with some distance without contact with the instrument. The second one, we don't need to worry about zero error. Why? Always we get the difference. Difference. Understood? Send message. Okay. Go to the tute. That's a full story of traveling microscope. Very simple. Okay, today let's try to complete this lesson. Now we got today 7th day. Now enough, we got time for this lesson. Next is start our very important lesson. forces. Okay, traveling microscope. The traveling microscope is a precision instrument used to measure small differences. Yes, small distances, lengths and diameters with high accuracy. Yes, high accuracy means no any contact, therefore no deformation. Deformations when we can get accuracy and no any zero errors, no zero errors, accurately we can get. It is widely used in physics experiment, mechanical measurements, and engineering applications. Engineering applications, right? Okay. The traveling microscope move along two perpendicular axes. Yes, that we can move along two perpendicular axes. Perpendicular axes mean vertical axis and horizontal axis. Horizontal axis. We can. I will show you by video. We can move along මෙහෙට උඩට පහළට කරන්න පුළුවන්. That's a vertical axis. We can move in up and down, adjusting up and down using this spool. And that we can move along horizontal axis like this. Okay, that we can adjust in two perpendicular axes, horizontal and vertical. Horizontal and vertical. The position of the micrometer is read from vernier scale attached to both axes. This vertical axis and horizontal both axes attached vernier calipers. Using vernier principle, we can get two measurement and get the distance, get the difference and to find the distance. Understood up to second point? If you have any doubt, please ask me. Give me a second. Okay, sorry. I good up to now? Right. Good, right? Hello. Good. By combining, yeah, what we discussed, the position of the microscope is read from the vertical scale, vernier scale attached to both axes. Yes, horizontal axis and vertical axis both contain vernier calipers, vernier scale. We can get measurements of two. We need two measurements and get the difference. By combining horizontal and vertical readings, the precise positions or size of an object can be determined. Yes, that we discussed. Okay, that is the instrument. That is the instrument. Okay, let's label some important parts, right? Okay, let's label. Make a tick up label. Not need all parts. This is a focusing knob. Focusing knob. Focusing knob. Focusing knob. This is the eyepiece. This is an objective lens. Objective lens. Objective lens. Objective lens. And this is a stage. This is a stage. This is a stage. The object is placed on this stage. And this is a horizontal adjustable knob. Horizontal adjustable. Please note down this adjustable knob. Please label your picture. Label your diagram. Okay. First label right side parts. Eyepiece, that means object. Focusing knob, objective lens, and stage. And this is a horizontal adjustable knob. Horizontal adjustable knob. This is a vertical adjustable knob. Vertical adjusting knob. Vertical adjustable knob. Vertical adjustable knob. Vertical adjusting knob. Okay, this is the vertical vernier scale. Rukshana, Rukshana. Rukshana. Yeah, yeah, you paid already, right? I have posted it Friday. Yeah, I posted it Friday. Yeah, මම ඔක්කොටම දාලා තියෙන්නේ payments කරපු අයට අද දෙන්නෙක් හිටියේ එයාලට විතරයි දාලා නැත්තේ. Two students paid today. They only need to post. Other all students I have posted. 3 to within Tuesday or Wednesday you can collect. Okay, this is vertical adjustable knob. Vertical adjustable knob, and this is vertical vernier caliper. Vernier scale, sorry, vernier scale. Vertical vernier scale. Vertical vernier scale. Vertical vernier scale. And this is the sorry. This is the horizontal vernier scale. Horizontal vernier scale. Okay, that enough. That enough. Basic parts. Basic parts. And this full part is a microscope, right? This with two objects, and that we call the middle part we called as focus tube. Focus tube and focus in knob. All parts are the microscope. Microscope. හරි. මන්ට දාග. Okay. Complete. Okay. Complete. Complete. Good. Okay. Okay, they are the main parts of the traveling microscope. Let's see. Base. Base or stage. Base or stage. Actually, the stage and this entire part is a base, right? This entire part. That's important to heavy and rigid to provide stability. Yes, it is important to provide stability for this vertical stand. Vertical stand, it provides stability. Stability. Provide stability. Okay. The function prevent vibration and ensure accurate measurements. Yes, we can prevent vibration, and it is very important. If it is any vibration, we can't focus directly, right? We can't focus perfectly. This cross line, it should focus accurately. If not, measurements can be varied. Okay, if you need accurately focus, the instrument should be stable. For stability, the base is very important. It's a rigid and heavy one. Avoid vibration, right? And vertical stand. Yes, these are vertical stand. This is a vertical stand, right? This vertical stand attached to the base. It is attached to the base. Yes, correct. It's attached to the base. And function supports the vertical movements of the microscope along the Z axis. That means vertical movements. Sorry, it is not Z axis, Y axis, Y axis. Y mean vertical axis, right? Supports the vertical movements of the microscope along Y axis. This is Y axis. It supports to the vertical movements. Vertical movements. Horizontal guide. Horizontal guide. It is mounted on the base of base for the horizontal movement of the microscope along x-axis. Yes, along x-axis. Horizontal guide means this part. This is part. This is a horizontal guide. Horizontal guide. Along this guide that we can move. This vertical part, we can move along this guide. Right? We can move along this guide. Allow precise lateral displacement for measuring position. Yes, we can get exact measuring position by smooth movements. By smooth movements, right? Just simply I have given for only understand. They are not asking an exam. Microscope tube. Microscope tube with the focus tube and focusing knob, right? The optical tube is the microscope containing objective lens and eyepiece. Yes, objective lens is the object side lens. Eyepiece mean eyesight lens, right? The magnified the object for precise measurement. The magnification is the purpose of microscope tube. Understood? They are simple. Vernier scale. There are two vernier scale, horizontal vernier scale and vertical vernier scale. Horizontal one and vernier scale. Sorry, vertical vernier scale. Scale attached to both axes to measure vertical and horizontal measurements. Okay, that's the purpose. If it is horizontal measurements, we can get by horizontal scales. If it is vertical measurement, we can get using vertical differences, vertical readings. Done? Good. Function provide reading to high precise. Usually this is a, I forgot, this is a least count of the instrument. Normally the least count, the minimum reading of the traveling microscope, it is 0.01 millimeter. Normal vernier caliper, it is 0.1 millimeter. Normal vernier caliper 0.1 millimeter, but traveling microscope, the least count 0.01 millimeter. 0.01 millimeter. That means 1 millimeter divided into 100 parts. And one part we can measure, it is similar to micrometer, no? Micrometer screw gauge. And adjustment, that is adjustments, fine screw controls very important to adjust the microscope in vertical and horizontal axis, right? Vertical and horizontal movements. And this illumination and clamps very important for the support. Okay. How to use traveling microscope? How to use traveling microscope? Give me a second. Rukshana, have you registered in our website? Website take register වෙලා දීම. Wait, let me check. Rukshana, are you there? Have you registered in our website? Oh no. I think you registered. If not, how I got your address? Rukshana. Okay, let me check after class. I got your missed address from website. Okay, let me check and inform after class. Okay, Rukshan? Okay. Okay, how to use this traveling microscope? What are the steps? Okay, they are the step. Now you already know. Place the object on the stage. Yes. Place the object on the stage. Adjust the microscope tube so that the object in focus. Focus means we can clearly observe these cross lines. Okay, that's a focus stage. Focus. Move the microscope horizontally using the screw and read the horizontal vernier scale. We can get the measurement using horizontal vernier scale and adjust by horizontal knobs, horizontal moving knobs. Move the microscope vertically if you need vertical measurements, vertically to measure higher using vertical vernier scale. Okay. Combine readings to get accurate reading or accurate distance. That means we can get the difference. If we need more accurate answer, we can use both vertical scale and horizontal scale. Both the scales we can use and get some average value. Okay, I'll show you. Get some average value. Okay, they are the applications. Okay. 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 Before next instrument, I will show you some video about traveling microscope, how to use this instrument. Okay, give 5 seconds. I'll find the video.
Hello students, how are you? Welcome back to my YouTube channel Physics Inside.
This instrument is traveling microscope and it operates along X and Y axis. This instrument is traveling microscope and it operates along X and Y axis.
X and Y axis.
Two vernier scales are attached.
X and Y axis mean X axis mean horizontal axis, Y mean vertical axis. That's a mean, right?
Vertically and horizontally.
Okay, this is a see, this is a horizontal vernier scale. Horizontal vernier scale. And this is a sorry, miss one. This is the vertical vernier scale, right? Vertical vernier scale. And this is a stage. This is a stage. And this is a microscope. And
by turning this knob, the microscope nozzle moves up and vice versa.
Up and down. Right? That's a vertical adjusting.
On losing this knob, microscope tube can be turned in this manner.
Yes.
Let's lock the
We can
microscope. On turning this knob, the tube can be moved forward and backward.
Yes. They all are adjusters, right?
Sir, we can't hear you.
Now okay, right? Tengah ni. Shiva.
Yes, sir.
Okay. Good. Okay.
This is the capillary tube
Tube.
with extremely narrow diameter whose radius we wish to find.
Okay.
Let's attach the capillary in the stand as shown.
Now they are trying to find the diameter of the capillary tube, internal diameter, external diameter also okay. Internal diameter using this external using this traveling microscope, right? But the thing they didn't use stage because we can't place on the stage, right? This type capillary tube we have to place vertically. It's a little bit difficult. It difficult to place on stage. Okay, that's why they have select another stand for place the object. Another stand, another vertical stand for place the object. If it is a flat object, we can place on the stage and we can get readings using method.
Place the traveling microscope in front of this capillary tube as shown. Please ensure a gap of at least 4 fingers between the microscope and the capillary tube.
Yes, I got always we have to the optimum distance is 4 finger distance. 4 finger distance. Right? No need accurately, but roughly we should maintain 4 finger distance, then it is easy to focus. We can easily focus.
By moving these two knobs, by trial and error method, try to get the visual of the capillary tube.
Yeah, see the cross lines.
Adjust the capillary circular bore.
Can you see
cross line? The crosswire of the microscope.
Yes. They are the cross lines. I told red color cross lines we can observe when we observing. When it is focused, we can very clearly see these cross lines with the object. Then we can move vertical and horizontal adjusting knobs and get to one edge. These cross lines get into a one edge, then get to the opposite edge. Then we can, using these two measurements, we can get the distance or diameter, right? Okay.
Cool. Take the horizontal and vertical readings on vernier attached to the microscope.
Okay, these calculations you don't need. I got understood. Any doubt? That's the end of traveling microscope. Any doubt? Now you can ask. Do you have any doubt? No? Good. Okay, let's move into the let's move into mass measuring instrument. That means length measuring instruments completed. Okay, what we discussed up to now, meter ruler completed, micrometer screw gauge completed, vernier caliper completed, traveling microscope now completed. Just now it's completed. Then all length measuring instruments already completed with all practicals. Practicals ඔක්කොම කරලා තියෙනවා. The problem, we don't have traveling microscope, but in my maximum I try to give you some practical idea, right? I maximum try. Okay, let's move into mass measuring instrument. In mass measuring instrument, nowadays use instrument is a electronic balance actually. But before electronic balance in laboratories, more than before 5 to 6 years, laboratories and whatever sensitive measurements got to get sensitive measurement, more sensitive measurements, more than electronic balance, used triple beam balance. Triple beam balance. Okay. Okay, that is a mass measuring instrument, and now it is not commonly used in laboratories, but previously used. Previously in laboratories to measure small quantity of chemicals, we use this triple beam balance. Triple beam balance, but nowadays everything everywhere replaced to electronic balance, right? Nowadays everywhere use electronic balance, the different types of advanced electronic balance. Okay, but you should have some basic knowledge about this triple beam balance. What are the concept and what are the steps of taking measurements using triple beam balance, and what are the principles here? What is the principle here? Okay. Okay. Come to the triple beam balance. It's a mass measuring instrument. It's a mass measuring instrument. Why we called as triple beam balance first? Why we call it as triple beam balance? The main reason, it has three beams. Three beams. Okay, that is the instrument. This is the instrument. Okay, I will show you more clear diagram. More clear diagram.
Instruments that we're going to use in science class.
Okay, this is a triple beam balance. This is a triple beam balance. Okay, for triple beam balance also, I will give you full practical idea. Complete practical idea එකක් දෙන්න පුළුවන් මේකේ. හරිද? Therefore, try to understand your maximum practical way. Practically use කරන්නම practice වෙන්න ඕන. හරි? Okay. Come to lesson. Okay. First of all, before moving to the instrument, let's identify parts of this triple beam balance. Parts of this triple beam balance. හරි. මේ බලන්න. Why we call this instrument as triple beam balance? It has three beams. Three beams. Okay. See, this is the first beam. This is the first beam. This is the first beam. Can you see this color? අපි ගත්තොත් blue. Now you can see that. Yeah, this is the first beam, and this is the middle beam, and this is the third beam. Oh, this is the first one, middle one, and third one. It has three beams. Three beams. Three beams. They are the three beams. Beams. Beams can bars are beams. Rods. Just rods. Okay. And these all beams, maybe all beams, very important. All beams are connected as a one beam here. All beam, all three beams connected to a one rod. එක beam එකකට connect කරලා තියෙනවා. Then the end of this single beam connect a measuring pan. Connect a measuring pan. Now clearly understand, get the practical idea, right? Three beams connected to a one single beam, and end of this lever connect measuring pan. This is a measuring pan, right? This is a measuring pan. Okay, now actually this triple beam balance is working according to the lever principle. What's the meaning of lever principle? Or that we call as moment of force principle. Moment of force principle that we discussed in the force lesson. Still you don't know the moment of forces, right? But you already know lever principle. Lever principle means, think this is a just single lever. This entire part is a single lever. Now this lever fixed here, fixed fix karla thiyena. This is a fixing part. It is fixed here. Now this is a measuring pan. Clearly understand, right? This is a fixed, this is a single lever. This is a single lever. Remember, this is a single lever, and this is a fixed point. This is a fixed point, and this is a measuring pan. Right? If we place any object on this measuring pan, what happened to the other end? If we apply any force on this end, the shorter end, what happened to the other end? See again, this is a lever, single lever, just fixed here, fixed on this point, and this shorter end connect a measuring pan. Yes, connect a measuring pan. And if I put any force, or if I place any mass on this measuring pan, what happened to the other end? It's moving up. Yes, rising up. Yes, moving upward. Okay, the same principle here. Okay, that's why we call the triple beam balance is made by lever principle. The principle of lever or lever motion, right? Lever mechanism, not motion, lever mechanism. Hurry. This is a measuring pan and three beams. Can you see there is a arrow mark? There is an arrow mark that we called as point. Or indicator. Pointer or indicator. Both correct. Indicator. Pointer or indicator. Right? Pointer or indicator. This one, can you see zero value with line, with small dash line. That we called as zero mark. And what is this? This is a base. This is a base, right? This is a base. And this is a measuring pan. Can you see on each lever contains some bars contain some masses. Okay, that they we called as riders. Riders. I will explain why we called as riders. Normally, this is 10 gram rider. This is a 10 gram rider. Remember, the final beam. Third beam rider is a 10 gram rider. It is 10 gram rider, right? Understand? 10 gram rider. The middle beam is contain highest mass rider. It is 100 gram rider. 100 gram rider. Remember, 100 gram rider. 100 gram rider. 100 gram rider. Okay. This is the smallest rider of the instrument that we call as 1 gram rider. 1 gram rider. Right? 1 gram rider. Okay. They are the main parts of the triple beam balance. Sorry. There is another special part. There is another important part that we call as adjustable knob. Adjustable knob. Adjustable knob. Adjustable knob. 1 gram rider, 10 gram rider, 100 gram rider, an indicator or pointer, and it has 3 beams and 0 mark. There is another one. It is not given in the tube. Please check this. Please check your tube. It is not given in the tube. This special part we called as extra bar holder. Ekat name karagana. Extra bar holder. 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 Okay. Can I erase? Can I erase? They already given in the tube. Please check, and if there are any missing name, you can label. Label karaganda. I think it is not given. The extra bar holder not given in the tube. Okay, you can draw this. It's just like a screw nut, screw nail. Screw එකක් වගේ තියෙන්නේ. ඒක ඇඳලා extra bar holder කියලා දාන්න. Complete. Complete. Pinuji. Good. Hashini. Complete. Nitira. Good. Now I'm going to erase. Now let's practice these parts. Let's practice these parts of the instrument. Okay, what is this? What is this? What is this? Measuring pan. Measuring pan, right? Measuring pan. What are them?
Riders.
No. They are the riders. They are beams, right? These rods are beams. Beams, yes, beams. What is this arrow mark? What's this arrow mark? Pointer, good. This is zero mark. And what is this supporter? That's base or stage. Not stage, it's base. And what is this nut? What is this screw?
Tear adjustment.
Yeah, tear adjustment or adjustable knob. Yes, good. Yes, they are the main parts and they are the riders, right? They are the riders. Okay, now we are going to focus more about these riders. One of the riders can be the Hurry. Can you see these values? Are they clear or not? Are they clear or not, these values? No. Wait, let me check. Give me a second. I will find clear diagram. Now clear? Sorry. We can't zoom this. Make it clear at the. Okay, wait, let me see. Now clear? It's clear, right? No?
Clear,
Then-
sir.
Yeah. Okay. See. Okay. First, come to the middle beam. Middle beam. Okay. If you come to middle beam, you can see. Oh, sorry. Middle beam. You can see it is calibrated 100 by 100. 100 by 100. 100 by 100. That means 0, 100, 200, and it is continue up to 500. Remember, it's continue up to 500. 0, 100, 200, 300, 400, 500. That's a middle beam. Middle beam is calibrated 100 by 100, and it is final, it is maximum 500. 500 is a maximum, right? The final beam, third one, right? Third beam is calibrated 10 by 10. 0, 20, sorry, 0, 10, 20, 30, 40, 50. I got. And it is continue up to 100. Understood? The middle beam 100 by 100. The final beam, third beam 10 by 10. Understood? Yes or no? Message done? Okay. Now, first beam, our first beam is calibrated 1 by 1. 1 gram, 2 gram, 3 gram, 4 gram, up to 10. Up to 10. Up to 10. Up to 10 is the maximum. And the most important thing, 1 gram distance. 1 gram distance on the first rider, first beam. 1 gram distance on first beam is divided into 10 identical parts. It's just like your ruler. 10 identical parts. 10 identical parts. 1 gram distance divided into 10 identical parts. I good. 1 gram distance divided into 10 identical parts. And other thing you need to understand, each rider there is an arrow mark, right? Each rider there is arrow mark. Arrow mark. There is an arrow mark. Okay, that's the second thing. Second thing, each rider has an arrow mark. Arrow mark. Next, the next thing, can you see middle one and final beam? Middle and final beams, some grooves are there. What are the meaning of grooves? Grooves can you see? Grooves. Can you see? See this middle beam and final beam, third beam. Can you see them? Yes. Okay. But is there any groove on first beam? No. First beam is very smooth. No any grooves. Hari? Okay. That's the summary you need to understand about these beams. Okay. Let's move into our previous figure again.
Hi, this is Mr. Blackman.
Okay. Now this is an instrument, right? This is the instrument. Hari. Now, what you think? What is the least count? Least count means minimum reading that we can obtain using this instrument accurately. The minimum reading that we can obtain accurately. What is the minimum reading? Any idea? What is the least count of this instrument? Very good, Hashim. Others, think. Now I explained about all beams. Think about beams and find the least count of triple beam balance. Think. Again, think about the calibration of beams. What is the least count of the instrument? Rukshana? Pinuji? Very good, Vinay. Okay, actually it is 0.1 gram. Why? Okay, this is the least count. If you got this first beam, it's calibrated by one, and each beam divided into 10, each 1 gram distance divided into 10 identical parts, right? That means the least count, the minimum reading that can be accurately obtained by this instrument, it is 1 gram divided by 10, right? 1 gram divided by 10 mean 1 gram divided by 10 mean 0.1 gram. Remember 0.1 gram 0.1 gram is the least count of this triple beam balance. Understood? Others? Devan? Kalidu? Good. Good. Okay. Okay. Now I will show you simply what are the steps of taking readings, taking measurement using this instrument. Okay, now you have full idea about instrument. Okay, I will show you, I will explain now, and I will show you what are the steps of taking measurements using this triple beam balance. It is very simple. Please focus into steps. Steps very important, and get some practical knowledge. Get full practical knowledge, not theoretical knowledge. Don't need. Maybe step by step. In exam, don't asking what is the first step, second step. No, if you have the practical idea, that enough. Okay, try to get a practical knowledge, practical idea, just concept. Okay, okay. First step, before take readings, the first step is clean the measuring pan. Clean the measuring pan. That's the first step. Clean the measuring pan, because if there are any dirt particle or dust particles apply on this measuring pan, it is coming measurement errors. Okay, therefore the first step, clean the measuring pan. Clean the measuring pan. Second step, check zero errors. Check zero errors mean after cleaning we have to get all riders into zero position. Again, left end like this. Get all riders into zero positions and check the pointer. If it is perfectly coincide with zero mark, no any zero error, right? It's very simple. If it is perfectly coincide, no any zero error, right? But if it is not coincide, it is the pointer going up or going down when it is zero, all riders at zero position, and now it is well clean. The measuring pan will clean and all riders are zero position. If it is not coincide, going up or it's moving up or down, it has a zero error. Therefore, but it is very simple, this instrument. We have an adjustable scope. We have a tear adjustment. Okay, what we can do? We can adjust, we can rotate by adjustment. We can rotate this adjustment until it is adjust into the line into zero mark, right? 2 steps done. What's the first step? Clean the measuring pan. Second step, check zero errors. How to check? Get all riders into zero position and check the pointer. Check indicator pointer. If it is coincide with 0 mark, no any 0 errors, no any problem, no worries. If it is not coincide, rotate the adjustment and get pointer coincide with 0. I got understood 2 steps. Understood? Third step, place the object on this measuring pad. Place the object on the measuring pad. Now, according to lever mechanism, lever principle, when I place any object on this measuring pad, what happened to the pointer? It's rising up or moving down? Moving up or down? What do you think? Up, right? Simply moving up to this. Make a gihim metanama vadina. It's hit. The pointer hit this upper end. Upper end. Right? I will show you. I will show you. Just understand. Okay. Next, we have, okay, place the object. Then what happened to pointer? It's moving up and it's moving up and go to the edge of this groove. Edge එකටම ගිහින් වදිනවා. හරිද? Hit the edge of the ground. Okay. Next, we have to start balancing the lever. Always remember, start balancing by start taking measurements from heaviest mass. Okay, now I have 3 riders. No, what is the heaviest one? First one or middle one or third one? First one or middle one or third one? Always, that is a rule. Always we have to start from heaviest mass rider. Heaviest mass rider. Then what is the heaviest mass? Middle one. Hurry. Middle one. Okay, now think I place the object and start balancing. Start take measurements with heaviest mass. Okay, now think this object on the measuring pad. This object and this 100-gram rider, that's the heaviest mass, middle beam 100-gram rider, shift into first groove. First groove. It's put into first groove. First groove means 100 gram. 100 gram. Now think there is no any change. The pointer is still in up. Yes, Shiva. Yes. Have you used this? Make a use kala tinaka. Great. Okay. But I am explaining very simply, but some students not use that. Okay. Think this 100-gram heaviest mass rider placed to first groove. First groove means 100-gram groove. 100 gram. 100 gram. 100-gram groove. Right? Okay, think still there is no any difference. There is no any change of the pointer. What's the meaning? There is no any change. The meaning, the object mass is greater than 100. Object mass is greater than 100. I got this. I place the heaviest mass into 100 gram. No, if it is no any change, the object mass greater than 100 gram. I got Harin. Okay, my second step, put the heaviest mass into second group. Second group means 200 grams. Okay, think when I put into 200 gram, the pointer become lower end. පහළටම වැටෙනවා. Passing 0 marks, it's come to lower end. What is the meaning? What's the meaning? The object mass less than 200. It is greater than 100 and less than 200. I got. Rukshana? The object mass greater than 100 and less than 200. Shiva? Harmit. Okay. Then what to do? Then what's next step? Now I found object mass less than 200. Then you have to again replace, again get rider into previous group, previous value. That means 100 gram. This 100 gram rider again get into previous value. Okay, that's the heaviest mass story. Okay, now heaviest mass, that means middle beam, 100 gram rider parts completed. Okay, next step, go to the next heaviest mass. Go to the next heaviest mass. What is the next heaviest mass? 10 gram, final one, right? Third beam rider. Okay, shift into 10 gram, no any change. Shift into, before that. Okay, what I did, first heaviest mass, first I shift to 100 gram, then I shift to 200 gram. When it is come to downward, pointer become downward, therefore I again go to previous value. Then what happened to the pointer again? Again pointer going to upper end. Understood? I mean 100 degree Okay, next, go to the next heaviest mass, 10 gram. Same method. Put into first one 10 gram, 20 gram, 30 gram, 40 gram. Think there is no any change. There is no any change up to 40 gram. But when it is shift to 50 grams, again pointer come to downward. Then what is the meaning? The object mass less than 150. It's already 100. It's less than 150. Again get rider into previous value. That means 40. Again pointer going up. Tirna? Hashini, understood? Seven? Senon. Okay. Now heaviest rider okay. Third beam rider okay. Now we have to start moments of first 1 gram, first beam rider. Okay, don't have grooves. We can smoothly move into right side. When it is slowly moving, we can see slowly change the position of pointer and okay, we can accurately coincide with 0 mark. When it is ideally coincide, we can stop the movement of 1 gram for final beam, final rider. Okay, think according to our measurements, we can say it is 100 gram, middle beam 100 gram, and final third beam I got 40 gram. Think it is 5.8 like value 5.8. Then you can say the object mass of the object 145.8 gram. 145.8 gram. 100, the reading 145.8 gram. I think you got the reason, you got the purpose. Then Viniji. The purpose purpose balancing, balance and get zero again, get pointer again to the zero mark, right? Then adding these to all rider position values, we can get the mass of the object, right? Hari, do you have any doubt? You can ask. Do you have any doubt? Sinon? Hi. Now I will show you. Try to get the full idea. Hi.
Balance is one of the most common scientific instruments that we're going to use in physics class. We use the triple balance to find mass of an object in grams. Today we're going to find the mass of this iron cube. To begin with, let's go over some of the features of the triple beam balance. Here's the pan. We want to make sure the pan is clean and free of any debris or water that might be on it before we start. If we don't, that could affect our results. We could be taking the mass of the water or whatever's on there instead of the mass of just our cube. These are the arms. We want to make sure that when we start, the weight that's on these arms are all the way down here. It's what we call having it zeroed. And we also want to make sure that we have this lined up right here with each.
Okay. He did first step done. He cleaned the measuring pan. The second step, now he did check the zero error. Now this instrument no any zero error, therefore no need to adjust.
But these little lines on each side matching. They're lined up. Now, you also want to note that there are little grooves on these two arms where the weight fits into. We want to make sure when we move these weights back and
now know any objects. When it is moving to first groove, it's moving down. Moving down because the right side is great. The meaning there is no any object. That means more than left side, right side mass is greater. That's why it is going down.
It falls into those little notches. Otherwise, we're not going to get the right results.
Now again, zero. Therefore, it's instrument correct.
The mass of this iron cube.
Now what happened? Now left side is greater than right side. Okay. Now measuring pan, when I place object, when we place object on the measuring pan, what happened to the pointer? It's going up.
So it's right away this end goes right up to the top. We're going to start with the heaviest
mass. Always remember. Yeah, no any change.
Yeah.
No any change. See? No any change. Continue. Continue. What's the mean? The object mass is greater than 100 grams. Continue. See, pointer come to lower end. The meaning, the object mass less than 200 grams, right? Less than 200 grams.
Yeah. Now we're going to move
again to previous one.
We're going to go to the next step.
Pointer again going up, right? No any change. Continue. No change. It's moving down.
Now we're going to move that one
back.
Finally, we're going to go to the lightest one, the smallest little mass here. Is tap it with your finger. Tap, tap, tappity, tap, 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 tap. There we go.
Now it is balanced.
Right, that's lined up pretty good. Right? And we want to try to be as accurate as we can with the triple beam balance. It can be difficult, but get it out of one of these lines that you see on that front bar. Now, how do we know what the mass is? What do we do with these numbers that they're going out? Well, let's go ahead and take a closer look to see what we really need to do in order to find out what the mass of this cube is.
Now you can clearly see the values of beams, right? It is calibrated 0, 10, 20 up to 100. The middle one, 0, 100, 200, 300, 400 up to 500. It is only up to 10. Only up to 10. Now what is this reading? Can you read this? 120. Okay, Balam.
Let's look at the largest one first, 100. So that's 100. When 120, and what's this one say? Well, it's right after the 5.
Okay. This is smallest mass, you have to be careful. It has very small arrow mark. You have to get the value in with decimal points. Okay, this is arrow mark. Therefore, this is the value. The value 5.56789. 5.9. Then 120, 5.9 is the value. That is the mass of this object. Understood? Yes, Sandhu? Sarindi? Senon?
Okay, before the 6. So that's going to be 125. How many lines over it is? 1, 2, 3, 4, 5, 6, 7, 8, 9. So 125.9. 125.9. Now, what are the units for mass? Grams. So we'd want to report this as 125.9 grams. Now that's the basics on how to use a triple beam balance. Make sure you practice.
Okay. Now we discussed everything. Okay, what do you think? What is the maximum measurement of this instrument? What's the maximum? The least count is 0.1 gram. What do you think? What is the maximum reading? Now it is 125.9. What is the maximum reading that we can obtain? Maximum reading. Good, Hashim. What's the maximum reading of this instrument? What's the maximum reading? Good. Others? Akhil? Khalidu? No. 125.9 is the mass of this object. I asked the maximum possible value of this instrument that we can obtain. Nitira? No, Aki. Good, Shivan, correct. By middle beam, we can get up to 500. Final beam, only 100. 500 plus 100, 600. First beam, it is 10. Remember, 610 is the maximum value. Good, Akhil? The maximum possible value is 610. That's the maximum reading that we can obtain. Yeah, 610 grams. 500, 100, 600 plus 10, it is 610 gram is the maximum reading that we can obtain. But I have a doubt. Think I want to measure 850 to 900 like value, 900 type object. Then can't we use this? Use karana buried. Say on what you think. Can't we use this for can? How to can? How we can use Hashim? How to use? Now these beams only given up to 610, but I want to get 800 to 900 3D measurement object. How to get this? Any idea? Any idea? Yes, very good. Others? Any idea? Yes, that's why I told it has additional option. The instrument supplier giving additional option for this type measurements. If you want more than 610 reading measurement, you can use additional bars. That's why we call this point I gave as this is an additional bar holder, extra bar holder. Normally, remember, when we get this instrument, the supplier provide 3 additional beams. 3 additional beam, 500 gram one and 500 gram one and 1 kilogram one. Overall 2 kilograms provided by supplier, instrument supply. Okay. Then if you want more than 610, you can get 500 extra bar hang on this point, right? If you want more than 1 kilogram, then what's the method? You can get 1 kilogram extra bar hang on this point, right? I got any doubt? Maybe. Okay, think you just want 805.2 gram reading using this instrument. Can you get this? You can't get using normal method. You can't get. Okay, you can use 500 gram extra beam. You can place here 500 gram extra beam. You can place on this extra bar holder. Then with this extra bar, if you got the mass of this object, instrument given value will be 305.2 grams. The instrument given value 305.2 grams. Then you should know 305.2 mean you already given 500. You already place holder 500 in extra bar holder. Therefore, it is 305.2 plus 500 gram is the final value. Understood? Kalindu? Understood? Okay. Hi. Okay, that's a full store. Okay, now tell me, final question. Using this extra bar also, using this extra bar, what is the maximum reading? What's the maximum reading even using these extra bars? Without extra bar, it is 610 grams. Using extra bars, if you use all extra beams, extra bars, extra masses, what is the maximum reading? Okay, what's the maximum reading? Great. What's the maximum reading? 50 cent. What is this? Yes, 2610 grams. No, Shivan. Shivan, it's 2 kilogram. 500, 500, 1 kilogram. Yeah, 2 kilograms plus 610 grams. That means 2610 grams. See, can you see this? It's already given here. 2610. This is a maximum read. 2610 gram is a maximum reading. What is the least count? 0.1 gram. Okay, that's a full story. Hurry. We have another 5 minutes only. Let's move into tute quickly. Tute එක මොනවද දීලා තියෙන්නේ බලමු. හරි. The lever method used in triple beam balance. Yes, I explained the lever method is a principle used in triple beam balance. In this instrument, a balance is used as a lever. Yes, we discussed. One side of the beam is shorter and contain balancing pan, measuring pan, right? Where the object to be measured is placed. The triple beam balance has 3 parallel beams. Yes, 3 parallel beams that we discussed, each with a sliding pointer, sliding riders. Pointer means sliding riders. These riders are moved along the beam to corresponding value on the scale. When the pointers on all 3 beams are adjusted correctly, the beam becomes balanced, indicating the torque. Torque, that means turning force, that we can discuss in the first lesson, on both sides of the levers is equal. The total mass of the object is obtained by adding the reading of all 3 beams. Okay. They are the all parts given. You have to mark extra bar holder here. Extra bar holder on here. And okay, a triple beam balance is a measuring instrument that works on the lever principle by moving the riders. That also discussed. The balance is adjusted until perfectly balanced. The mass of the object is then obtained by adding 3 readings that we discussed. The least count of the triple beam balance is 0.1 gram, and the maximum scale without additional extra bar, it is 610 gram, right? However, additional 2 kilogram, 500. Wait. However, additional 2 kilogram and 500 gram hanging weights are attached at the end of the lever arm. Yeah. It should be, however, additional 1 kilogram and 2 500 gram hanging weights. 2 500 gram. Okay, mema hambenne 1 kilogram, 1 kilogram and 2 500 gram. Please note down. 2 500 gram. Right? It is not 2 kilogram. 1 kilogram ekai, 500 gram dekai. With this extra bar, it is maximum 2610. 2610. Okay, obtaining measurements, check the zero reading, place the object, I have everything given, adjust the largest beam, adjust the second largest beam and smallest beam, read the measurement by adding all measurements. Okay. Can you read this? Can you read the mass of this reading? This heaviest mass 400. Yes, very good. Heaviest mass 400. Great, 444 grams. Perfect. 444 grams. Okay. Zero error of the triple beam balance. Actually, we don't need to worry. We can check and adjust by tear adjustment, right? Tear adjustment. That's the end of triple beam balance. Today we discussed traveling microscope and triple beam balance, two instruments. Next week is the final week for final day of measurement lesson. What is the next week? 3rd of May. 3rd of May, if we complete 3rd of May, we have another 4 days. We have another 4 days to in May next one. No? But the problem is 31st is spoiled, you know. Okay, let's take extra time and start false lesson next month. Okay, do you have any doubt today? Today lesson? Do you have any doubt? Any doubt? Akhil? Okay, now we completed 5 instruments, right? Meter ruler, vernier caliper, traveling microscope, micrometer, screw gauge, and triple beam balance. 5 instruments done. The remaining instruments very simple. At the time, within 1 hour, 1 to 150, 1 hour and 15 minutes we can complete. And I hope to give some idea about questions, A-level questions, MCQ and essay type questions, the basic introduction about questions in A-level in next week. Therefore, don't miss next week class, very important. And okay, that's all. Okay, don't miss next week class. It is very important. I will give you, because we in measurement lesson we have only very small part. After completing this part, we can discuss some how to MCQ paper and how MCQ questions and is structured essay questions coming by this instrument. Exam structure and question structures we can discuss. Okay, that's all for today. No doubts, right? Okay, then let's meet on next week 6:30 p.m. Goodbye. Good night.